This is Neelam Pathak, and I am the founder and CEO for VIMA, which is Women in Manufacturing and Allied Industry. As a part of the VIMA Skilling Series, every month we take two webinars and or master classes where we are trying to have more information about the various future skilling courses that's been coming up. In the same series today, we are going to have more information sharing by our professional consultant, Mr. Ramana Kumar, on the Industry 4.0 foundations, smart manufacturing, and the data-driven decision making. Now, why this topic, why it is important, and why we need to have a brief of this, it's very, very important onto that. As we know that to make the manufacturing more intelligent, more agile, and more data-driven is very, very important to understand for all the organizations, including the MSMEs, that how the real-time data impacts the decision, and that is why we thought at Pima that it's important that we should have this master class or introduction series. The thing is we are also coming up with a detailed course into smart manufacturing and industry 4.0, which is called smart manufacturing industry 4.0 accelerator program, which is a more in-depth detailed program. If any one of you would be interested, we are going to post those links into our comments here. Do register yourself. This program is going to start from April. And today, let's hear more about this smart manufacturing and a brief of this from Ramana Kumar. To introduce Ramana, Ramana comes with more than 20 years of experience in the manufacturing industry, and he has been a trainer and a consultant into the smart manufacturing and data-driven decision-making areas. Now, I'd hand over to Ramana. I have only one request to all the audience who are listening to us today. If you have any question, please put it up in the chat, and we are going to take all the question at the end of the last 15 minutes. Thank you, and over to you, Ramanna. Please take it.
Hey, hi, good evening, everyone. Thank you, Neelam ji, for an extended introduction. And yes, guys, I am here, Ramana Kumar Musunuru, a 20 years plus experienced industrial expert and a lean management professional, business excellence guide, and also a certified QMS professional, very well versed with industry 4.0 planning and implementation in many stages in my uh, 2 decades of experience into various manufacturing industries like automobile, electrical, and electronics. Yes, I have a passion for rewriting, exploring, teaching, and learning too. That made me become a management consultant and a corporate trainer all these years. So over the years, I have seen manufacturing evolve from manual process to automated processes, and also I have seen many times we uh, wait for data, we look into data, we try to retrieve data. Yes, but let me begin with a simple clarification. Industry 4.0 is not about replacing people. It is not about buying expensive softwares, or it is definitely not about building technology to have technology. Yes, Industry 4.0 is all about intelligence. It is all about connecting machines to the process and to the people through data, so that decisions are faster, smarter, and predictable. And in many organizations, decisions are still reactive. We see this day in day out. When I visit many organizations, I see it. If a machine fails, then the reaction comes, then they run for the replacement or buy the spare. Or in some ways, if in some cases, if there is a customer complaint, then the people rush to correct it, or to segregate the non okay material. And if suddenly there is an abnormal drop in the productivity, then people go to investigate it. So all this is a reactive methodology. But Industry 4.0 changes this approach. It shifts us from being reactive to being proactive, and building the predictive methodologies of being attentive towards our shop floor, because our machines talk to us. Our machines inform us lot of things. They give us lot of data. But only thing is we need to listen to it. The communication between machines and the top floor, the communication between shop floor and top floor is Industry 4.0. In today's session, we will build a strong foundation by understanding three key aspects. The first one is what Industry 4.0 really means. The second one is what smart manufacturing looks like in practical terms in the shop floor, what exactly smart manufacturing is. And the third is how data driven decision making transforms our shop floor's performance, how it can increase the efficiency of our shop floors to that extent. Yes, why Industry 4.0? Before going into this, the goal for this session is very simple. It is not to overload you with lot of technical information, lot of knowledge. It is only to give you a clarity, to create a structure and a practical perspective that you can correlate your organization's day-to-day activities into the technology, into the system. Yes, so let us begin with exactly what is Industry 4.0 and why Industry 4.0 has become a buzzword. Now we all hear day in day out Industry 4.0. Slowly we are also hearing Industry 5.0. So yes, manufacturing today is under tremendous pressure, if I have to say. Customers want quick deliveries, faster deliveries. We all, as a customers, we all expect 10 minutes delivery, the quick delivery, quick commerce. So somewhere the manufacturing needs to keep in pace with the customers requirement of faster delivery. At the same time, customers are also expecting a zero defect culture. So we as a customer, we also expect whatever small item we purchase, we want it to be a defect free product. At the same time, we are also expecting more customization. So each and every customer looks towards customization, but definitely not at an increased cost. The cost should be optimized. At the same time, we do have global competition, global intense competition from very many global entities. Many people are looking towards India. They are trying to enter into India. India is with open doors. Industry 4.0 is definitely not a trend. Yes, earlier operational excellence was enough. Like pre-COVID, if you have to see, operational excellence was very much enough to manage the shop floors, to manage the customer requirements. But now, in today's scenario, visibility, agility are equally important. So the response towards Industry 4.0, if I have to say technology point of view, yes, there is a complexity, and we are trying to simplify that complexity today towards certain extent. The main important point here is organizations who cannot see their operations in real time. It is like data speaks. When we can't see our real time data of the shop floor, yes, we can't improve ourselves, we can't make ourselves a world class entity. That is why Industry 4.0 is very relevant now in this competitive scenario, to say post COVID. Industry 4.0 is a decade old concept. We are heading towards Industry 5.0, the connect between system and people. But definitely the traction in Industry 4.0 has come in past 3 4 years post COVID, because of the global competition, because of the tariffs, because of many other factors and scenarios. Yes, before going more deep into what is Industry 4.0, just for a brief context, I want to make you understand where all this industrialization has started, how Industry 1.0 started, how people during that days identified steam can generate mechanical power. So steam was used to revolutionize the productivity, production activities, and all. So slowly going ahead, for after 2 to 3 decades, people identified, or we can say something created electricity. So electricity was created, and electricity changed the pace of industrialization. Mass production was brought into picture. A lot of machines were brought into picture based on electricity. So converting electric energy into mechanical energy has made a revolution, to say. So that is industry 2.0 revolution. So coming to the scenario of 90s, or starting of 2000, we were with industry 3.0, the automation. So computers crossed the boundaries of labs and they entered the shop floors. They became compact, they got themselves tucked into the machines, and we started using machines, CNC operated machines, numerically controlled, computerized, numerically controlled machines. So where precision has become a regular scenario, where precision was a easy factor, a common factor in the industry, in the shop floors, what we have to do, what we do every day. So because of the numeric controls, because of computer aided designings and computer aided programmings, precision has become a very easy thing with industry 3.0 revolution. So then came the industrial revolution, fourth industrial revolution, industry 4.0, the very important buzzword. So it did not change something from, did not take away something from industry 3.0 revolution 3, but it added intelligence to those computers. It got us connected, it got the machines connected to the desktops, to the dashboards. So it added intelligence. Data analytics started pouring into the shop floor. So industry 4.0, the major revolution in in the industrial part. So where intelligence got added. Yes, as I told you, we are heading towards industry 5.0 today. So industry 5.0, I'm not going to make more focus on this, but just only a heads up that it is more about personalization. So it is somewhere collaboration between man and machine. Industry 5.0 is all a collaborative scenario between man and machine. How can we integrate or we connect both of them? So this is the industrial revolutions, and this is how industry 4.0 has evolved across the year. Yeah, now coming to the main topic, what exactly is industry 4.0? So as I can tell you, so, and I told you just now, so connecting the machines to the system, and from there to the data analytical softwares or the portals, or then creating a very good analytical dashboards or analytical pie charts, pictures, diagrams, whatever we say. So industry 4.0 is all about connecting the machines, getting the real time data, integrating it with softwares which can do data analysis, and giving it or displaying it on the dashboards for intelligent decisions. So as I told you, without industry 4.0 we all are reactive. So industry 4.0 takes us from being reactive to being predictive, and going ahead being predictive. Yeah. And if I can say once again what industry 4.0 in a raw language, it is very simple. Like we can say machine talks to the system, systems talks to the dashboard, and dashboards guide us for taking intelligent decisions. So earlier, before industry 4.0, data was there, data was recorded, shop floors used to have lot of data, but that the trustworthiness of the data, or the reliability onto the data, or retrieval of data, or visualization of data, or decision making from data was the complex thing. Now data is real time, data is reliable, apt, and with that we are also having additionally analyzed data in a better visualization form, where we can use it quickly to take apt decisions, correct decisions at the right time, right decisions at the right time. So That is the journey from being reactive to predictive, predictive to perspective. So this is the real transformation what industry 4.0 brings in our journey. Yes, coming to the next part. Now we understood what industry 4.0 is, and we were justified. It definitely transforms our shop floors, make them more efficient. Now it is a time to understand what are the pillars on which industry 4.0 is built. What are the core pillars of industry 4.0, how industry 4.0 works actually. So if we can see, industry 4.0 has five core pillars. So they are the cyber physical systems. So in simple words, in non technical or the shop floor language, to say, this is the digital twin to your machine. So you have a machine, it is operating in the shop floor, it is running in the shop floor. So definitely there is a start time, stop time, everything. So the moment it gets connected with industry 4.0 application, it has a twin, it has a digital twin. That digital twin is on your desktop, on your dashboard, where it shows what is happening on the machine. So this is the cyber physical system what industry 4.0's first pillar is. It is like machines integrated with the digital systems, creating their digital twins. The second pillar of Industry 4.0 is the IoT, industrial IoT, precisely to say. So it is the industrial Internet of Things. So today everything is connected to Internet. Our computers are connected, our laptops are connected, our mobiles are connected. The funniest thing is even our toothbrush is connected to internet today. So data is there everywhere, data is part of our life, and how to collect and compile the data is the toughest part. So that part, the tough thing is simplified with the IoT devices, the internet of thing devices. So industrial IoT devices are basically sensors, basically any kind of electronic device which catch or which collect the data, various data points from the machines, where there is a mechanical rotation happening, where there is a mechanical change point happening. An electronic device actively at the real time collects that data. That device is the IoT device. Then the third pillar of industry 4.0 is the connectivity and cloud. Yes, the IoT device has done its part. It is tapping the data points from the machine, it is collecting data points from the machine. It can be from PLC or it can be from any other rotational or moving object in the machine. Now the data is tabbed and collected, compiled in the IoT devices. That data needs to move to the software for getting analyzed. So internet is the connecting point. Internet collects the data, moves it to a storage area called cloud storage area. All the data at the real time with the backup gets collected in the cloud through internet connections. So scalable infrastructure for data access is the most important pillar, the third pillar, core pillar of industry 4.0. So this third pillar makes the machines access from anywhere. The fourth pillar is big data and analysis. Now, as I told you, shop floor has lot of data. We all generate n number of logbooks, check sheets. We generate many data information reports. So all the data now at a precise stage in a real-time environment is getting collected, compiled by the IoT devices, being moved to the cloud infrastructure, and the cloud is having lot of data. So here the APIs, the softwares come into picture. They start analyzing the data, they start deep diving into the data, they research onto the data, and they give us analytical information on the data. So that data which reflects the machine performance, machine operations. So ultimately we have an analytical visualized data of our machine, of whatever is happening in the machine. The last pillar is automation and integration. This is the most important pillar of Industry 4.0, which the industry is focusing in last few years, couple of years from now. So post COVID to say, in fact, so seamless workflows across all systems. Yes, data is collected, machines are generating data points, data points are being collected by IoT devices, they are connected to clouds, they shift the data to the cloud, then a software comes into picture, an API comes into picture, it understands the data, analyzes the data, and produces us in a visualized manner which will be easy for us to understand. Automation here comes into picture. It integrates our departments and systems. So the moment if a machine stops in a shop floor, the automation part or the integration part immediately inform the maintenance department a machine got stopped, rush there. So nobody needs to call the maintenance team, nobody needs to send them a message. The system itself sends them an alarm and they rush there. If there is a rejection, if there is a visual defect in a part, if a part is not as per the design or is not as per the dimension pre-specified, the quality team is given a notification, that quality team is informed directly automatically by the integrated softwares. This is the fifth core pillar, the most important pillar of Industry 4.0. Coming to the next part, smart manufacturing. So yes, we understood our shop floors are having lot of data, lot of access points, lot of things happening in shop floor. So there is a real time dynamic activity happening continuously in the shop floors. We see this every time. So what smart manufacturing means. So how is it an advanced step of Industry 4.0 is very important and one of our topic for the day. So in smart manufacturing, there are three important things. One is real time visibility, second is integrated processes, and the third important thing is predictive actions. So as we spoke about Industry 4.0, the pillars what we have spoken about in Industry 4.0 slide are only tools. So they they only help us in connecting, they only help us in visualizing, but making value out of that is the important thing. That is how we have to use them. Smart manufacturing helps us in creating value from those core tools of Industry 4.0. Before discussing more about smart manufacturing, I openly want to say many organizations understand Industry 4.0 conceptually. This is nothing new, it is a decade old concept. Everyone today has access to basic information about Industry 4.0 concept. But the struggle is with implementation, the struggle is with sequencing. How we deploy the concept onto shop floor, how we make our shop floor an active place where the data comes to us on real time basis in an effective manner and we can improve the efficiency. That is where smart manufacturing comes into picture. Very important point to say here is smart manufacturing is not about robotics alone. It is about real time visibility. It is about visualizing the data in a more effective way to understand it in a more simpler way. So it doesn't only say that smart manufacturing keeps people away from production. No, we ultimately should be there to do the production. It is not only robots alone can do everything. For example, we know a machine is performing right, we should understand whether it is performing right now or whether it is not performing. It should not be a case with the manager that until tomorrow morning he doesn't know his machine got stopped midnight 2 o'clock in the night shift due to some reason. We should know our energy consumption trends at real time basis. We should know any malfunctioning happening in the machine at real times. If a motor is generating more heat, we should able to be know it at the time before it gets burnt out. So our energy consumption should not be a monthly total bill, not that we know it at the end of the month or next month 7th when the electricity bill comes. We have this data on real time basis, so we can improve it in the next minute, not even the next hour. At the same time, if there is a malfunctioning, if there is a defect getting generated, the moment we have the data, the moment we can react it immediately and see that we don't produce defects, we don't spoil our machines, we don't end up in losing valuable time. So smart manufacturing means system alerts which we get before some abnormal thing, some unwanted thing, or some unexpected thing happens in the process. So the problem gets escalated during it is happening itself. With this, we will be having a lot of shop floor intelligence, which helps us in being more proactive or predictive, as I used these words earlier. So this is how smart manufacturing helps us. It helps us in having good OE dashboards. It helps us in having good monitoring over the machines. It helps us in tracking our resource consumption. It may be our manpower resource consumption, our energy consumption, our spare parts consumption, our non raw material consumption or raw material consumption, anything. So it has an end to end traceability of our consumption patterns. Yes. Before we go further into the details of smart factory, we may have a query, we may have a thought process here saying that all this data is there earlier, and if I have traditional manufacturing setup, I can do this monitoring by myself. This may be a thought process what we have. So a brief difference between traditional and smart way of factory setup is here. So in traditional manufacturing, we have manual data entry, which I don't say creates a lot of defects, but definitely manual errors are part and parcel of our shop floor lives. We should accept that point. The most important thing with manual data entry is delay. So we can't every time stand in front of a machine and keep on writing the data for every second what happened. So there will be definitely a delay at least by an hour or by 8 hours. Apart from that, reactive method of approach. Traditional manufacturing has a reactive method of approach, so which may increase our lead times in repairing the machines, or in getting the raw materials, or in arranging spare parts, in getting correcting the quality issues. We all have certain lead times which are unavoidable in traditional manufacturing way of methodology. We have departments in silos. Everyone works in their zone. Everyone prioritizes their activity, what they are having on hand in traditional way of manufacturing, because they are not visualizing what is happening at that point of time in an other zone or other area or other department. The most important thing in traditional manufacturing is the delayed decision making. So delayed decision making will cause us losing many opportunities. It may We may feel that if I would have known this first, I would have saved this lot of material. I would have saved this batch of production. I would have saved a lot of raw material. I would have stopped this machine from getting breakdown, or I would have stopped this spare part from getting worn out or end of life. All delayed decisions make us miss many opportunities. So on the controversial side, smart factory helps us in with real-time dashboards, provides us instant data points, visibility towards the data points, with which we can have prediction on what is going to happen. We can have visibility on what exactly is happening at this moment in a department which is maybe walls away from me. It also integrates across cross-functional teams. The data is easily flown across cross-functional teams, which helps everyone in making quick reactions so that they will be available on the shop floor at the time of need or the time of point of requirement. Same way, the fast decisions create uh, good benefits, like we can capitalize on the losses, we can avoid losses, and we can improve the efficiency, we can capitalize on the efficiency. So the difference between traditional manufacturing setup and a smart factory is very simple. The dashboards here are live, they are on real time basis, they are updated on real time basis. So we have we have the efficiency of predicting, maintenance departments have the efficiency of predictive maintenance. Our systems are integrated, our decisions are data backed, not vague decisions. So we have many advantages with smart manufacturing. One important point, the difference between traditional manufacturing setup and smart manufacturing setup is not the machines, it is the visibility and the integration. So the moment we have visibility of what is happening on the machine on real time basis, the moment we have the shop floor integrated with cross functional teams with multiple departments, that makes the factory smart. That is where, in many corporate workshops, I usually work with teams to create a step by step Industry 4.0 roadmap so that they can integrate all the departments, they can flow the data between all the departments without any hurdles, and they can keep themselves ready for the unexpected things what may happen. So this is the difference between traditional and smart factory. So, coming to the most important topic of today, data driven decision making. So, in short, we call it DDDM. So, yes, data is available in our shop floors. It is available from 1960s. Our Japanese, to say seniors, Japanese experts taught us many ways how to collect data, how to uh, put up data in front of the on the table, how to use data, how to react according to the data. But decision making is the point where data is being used very at a delayed pace till before Industry 4.2. The important point here is, if we have the data right on the spot, if we have the data exactly as we expect or easy, it is visualized easily for us to understand, and at the same time if we have an intelligent software backing the data to show some predictions according to the data, to show some, to give us some alarms, to give us some notifications based on data, that is where our decision making power is exponential. We take correct decisions, we take apt decisions, right decisions at the right time. So how data driven decision making works, as we can see here in the uh, picture, is data, the raw data, as I told you, which is in the hidden in the machine shop, hidden in the machines. The raw data is collected through sensors, logs are created, the log data is processed, it is segregated, it is cleaned, it is transformed into various forms of inputs, how it is decided or designed by the software. So the software gets a transformed input and it starts providing insights for us. So it identifies patterns, it identifies abnormalities, it identifies sequences. So the software works on all these factors and create insights for us. With those insights, we have the power of deciding. We can select a correct strategy, we can choose an apt strategy which helps us to take a very good decision. We can act on quick fixes, we can act on instant fixes. To say it, to make it more clear, to make it more simple, I can say data is a raw number. Okay, so I produced 2500 2300 parts yesterday, very raw number. But information is a structured data. I produced 2300, 2400 parts at 300 numbers per 8 hours is the information. Insight is a interpretation of the information. Yes, at the rate of 300 numbers per hour at 8 hours shift, we produce 2400 numbers. This is the information, this is the structured form of data, but there is no insight. The insight here, what software provides us as a part of Industry 4.0, is at the first hour how much production has happened. Is the second hour production more than the first hour, or did it drop? Is there a lag in production post lunch break? Is there a startup loss or a end of the shift loss? All these things are the insights what we have from the interpreted information is interpreted for all these types of insights. With these insights we can make actions to improve our shop floors, to make them more efficient. So for example, production dropped. So a traditional response what we get from a shop floor supervisor is an assumption, is a assumed cause. Like he may say, yes, the operator is not available for 30 minutes, or material movement time took more than expected, or specified cycle time. There is a problem in the machine stopped for 10 minutes. As it is not 30 minutes, it did not get recorded in the maintenance department. So we get all assumptions from the shop floors the moment we go with traditional response. But a data driven response will be totally different. It gives us a very deep insights, like which machine, which shift, which parameter changed, when did it stop, when did it start, how the trend has happened, what is the analytical trend. This is how a smart shop floor generates data and makes it visible on the real time basis. So this reduces assumptions and also increase the accuracy, reliability towards data. And that powerful data is used to take powerful decisions which increase the efficiency and reduce the stress on the shop floors. It can be the human stress reduction, or it can be the machine problem reduction. So coming to the next stage, yes, we understood data driven decision making is very effective. It gives us a lot of efficiency. So how to digitalize the data, how to visualize the data in the digital front is the most important thing. That is the foundation for any smart manufacturing setup, if I have to say. So for having a digital twin, for having a digital shop floor, a smart factory, we need to have stable processes. We can't say today I will feed A process to the machine, tomorrow I'll feed C process to the software. No, it can't happen. We need to have stable processes. We need to manually work out on our shop floors. We need to focus on our process quality control tables and sheets. We need to have a strong control plan and SOPs. Then we can consistently, repeatedly give the same kind of data points to the softwares. The IoTs can collect that same data points every time if we have a stable process. The SOPs, the best practices, what we document needs to be implemented in the shop floors, needs to have that same practice happening or deployed in the shop floor, because softwares work on SOPs. As I told you, control points, control plans, they have checkpoints. They are established with manufacturing controls. They are established with product controls, product performance, process performance, all these things. So our control plans should be strong enough so that we can feed the software, we can give input to the software that this is the abnormal condition and you need to keep me informed on the real time with this abnormal condition. So control plan is the most effective way how a software can notify us if there is any abnormality. The final thing is the FMEA, process failure mode effect analysis. So this is the main area where we identify the risks in the process, we identify the mitigation methodologies for those risks, and we keep our systems prepared for those risks. We keep our softwares, we give input to the softwares where they have to raise an alarm, where they have to give us a notification if a risk is going to happen. So we can be prepared, we can make our technology be prepared for those mitigation activities. The most important factor, foundation point in digitalization is data discipline. So the data needs to be very accurate, it should be timely, it should be culture based, it should not be bypassed, it should not be tabbed, it should not be interpreted manually. So that discipline is the foundation for digitalization, and industry 4.0 starts with process discipline. It doesn't happen with technology, it doesn't happen with putting lot of robots, or it doesn't happen with putting lot of digital boards in the shop floor. Without foundation, technology can't do anything. Technology fails without foundation. The important question what we have to put to ourselves is, before planning to have industry 4.0 deployed, or before planning to have smart factory, before making ourselves ready for smart factory, is our organization industry 4.0 ready? Are we ready for Industry 4.0, or are we only curious towards Industry 4.0? Are we only being pushed by our OEMs, or we really want to be an effective shop floor? So this point is very important before we learn or deploy Industry 4.0 as a process in our factories. So coming to the almost to the final stage of today's discussion, challenges in Indian industry, where we are more like 80% of our industries are MSMEs. So we have a lot of challenges. The first and most important challenge any Indian industry faces for making a smart factory, for creating a smart factory, is capital investment. So a lot of capital investment comes into picture, high upfront cost, uncertain paybacks, all these things we can't estimate the ROI. The smart factory ROI is not tangible, it is an intangible benefit. So we can't make it visually, we can't project it to any funding purpose. It can be through promoters or any investors or any banking sector. So capital investment is the biggest concern, the most important concern, and that is where we as Vima are trying to fill in, is the skill gap. So today 80% of our workforce lacks digital expertise. They don't have app knowledge towards what digital twin means, what a smart factory means, how it operates. Moreover, we believe on myths that smart factories replace human beings with robots. So no, that is a very wrong thought process what we are going towards. It is not that way. So we need to improve our skill, we need to train ourselves, we need to improve ourselves to be in pace with the smart factory requirements. The third important thing is resistance to change. So many times we observe in many shop floors, uh, sometimes the top management has the commitments towards changing towards smart factory, but the shop floor has a lot of resistance. They feel that they will be monitored continuously, they will be having a lot of pressure on them for being on far or on run. No, that is not the thing. The moment top management has apt data, the moment top management has correct data, they can take wise decisions, they can provide us with more efficient tools, more efficient equipments, to make our work more easily. We can't every time reflect what we are looking towards. So data shows certain important inputs to the management. With that, our life will definitely be easy on the shop floor. The fourth challenge what I personally faced on many projects is integration. So probably the data points collected and visualized across cross-functional teams are not same, not common. So there will be a lot of age-old systems in the methodologies, in the standards. So the way they follow, the way they understand data is already set for across years. So people find it difficult to change. Because of that, there will be a difference between cross functions. So integration is the toughest challenge what we face in implementation of industry 4.0. And as I told you, MSME sector faces these challenges more than the large scale industries. The challenges have a lot of these things in the MSME particularly. So my input, or my, I don't say advice, my point of view with all these years of experience is, we make a mistake, we try to jump directly into advanced systems. That is where we end up in lot of capex. So important thing is we need to start small. We need to start with one or two machines in the shop floor. We need to pilot the projects. We need to focus on digitization. We need to focus on integration. We need to understand the data points, understand the analytical visualizations, reports what we get, take wise decisions, make certain benefits, then scale it digitally, mature the process. Otherwise we end up with lot of confusion. The moment we try to integrate all machines at a time, we end up in big challenges. So coming to the last part, I'm almost done. 3 minutes to go ahead. So the way forward, what we have to do to go ahead with Industry 4.0, as I told you, start small, build a culture of data, integrate gradually, don't rush across the integration process, upskill people. Without people managing the data, without people managing the shop floors, nothing will happen. Most important thing is we have to think this as a long term activity. This doesn't help us in short term, it doesn't give us short term benefits. Smart factories are built by smart processes and disciplined people. So that is where we need to make it a very very important thing. So we have to start with stability, process stability. We have to create data discipline. We have to build visibility. We have to upskill people. We have to integrate things gradually. So Industry 4.0 is not a one time project, it is a journey. We have to realize that point. The most important thing what I tell to many small scale industries is technology cannot, it can be purchased probably, but mindset needs to be developed. We can only purchase technology, but the mindset needs to be developed. And organizations that combine process discipline with the digital intelligence, they will lead the future. They will be effective, more efficient shop floors. So this is what is from my side, and open for questions.
Thank you, Prasanna. I hope our audience who are listening and viewing us would have got the gist of the smart manufacturing and data-driven decision making. We have few live question, Ramana, which we are going to take it now.
Yeah.
But before the questions, to tell our the viewers who are listening to us that this is just a gist and a brief of what we wanted to share it. But as a part of having and taking it more in depth, we have launched a program called Smart Manufacturing and Industry 4.0 Accelerator Program, which is a 6 module program, and each module is of 3 hours. We have both the options of offline and online. Naturally, we take offline classes for the corporates, but online is for the individual who would like to get. It's a certified program for 6 module, which is taken on the weekend. If you are interested, because there we are going to take it the practical application of it, how the smaller companies or the medium companies they can implement this. The also helping you make a roadmap for implementation of this into for your organizations, and this is what we are going to take up into that program. The online program is going to start from April. We have already given you the forms. If you are interested, please fill the form and our team will come back to you. Now, coming to the live questions, Ramana, we have a viewer, Mr. Rao, who has asked, and in fact, you have already taken the challenges in implementing this smart manufacturing, but I wanted you to also touch base on some more on the practical aspect of it. And he has asked that what is stopping many manufacturing companies to migrate to smart factories? Is it the investment or the technical challenge to convert from the existing conventional manufacturing? So what, like as I was saying, you've already taken up a slide, but if you would like to take up more practical approach and wanted to answer on this.
Yes, Mr. Rao, that is a really good question because that is where implementation is the most important part, and that is where many organizations, we as manufacturing organizations are failing. So it is not about understanding the concept. We understood the concept years back because, as I told you, this is a decade-old concept. As I discussed with you, the practical problems what I faced in shop floor many times while integrating the shop floor data with the top floor data, the most important point is the clarity. So I don't want to again recap on these 4 5 challenges what I'm showing on the screen. I would want to go off the topic and talk about the real scenarios. It is the most important point. There is the clarity. So the decision makers, it is a top driven approach. The clarity will come from the top. So the decision makers need to clarify to the industry 4.0 development teams or the shop floor teams what exact data they are looking towards, what is the data point they want at what point of time. It is not that having everything on my database doesn't help me out in that point. So there is something called a difference between noise and skill. So we should not have more noise on our dashboard. So yes, the industry 4.0 helps us in knowing when a machine is started, when a machine is stopped. But I don't think so a CEO has something to do with the starting time of a machine and the stopping time of a machine. So the important point is what is the data point he wants to have it on his dashboard. So we need to focus on a user specific dashboards. If an user is a production manager, he needs to have a data about the machine timing, the machine quantities, the machine quality output, or the machine breakdown timings. But he need not be more inclined towards data points like how much energy is being consumed. Yes, he needs to have the data, but it may be once in a while, not on a real time basis. It need not be on his dashboard. Many times I find many dashboards complicated because the clarity was not there on what user to have what data on his dashboard. That is where industry 4.0 projects look like huge dump of data but not a useful data point. Hope I justified to your question.
Thanks, Ramana. We have another question from one of our live user, and that is Mr. Om Prakash Sahu. He is asking that is there any way to predict the ROI before adopting the implementing Industry 4.0? Like he's just saying that whether the historical data collecting from those industry who are already implemented, is there any trend line or anything that can be predicted that okay, if we do this, if you implement this, this is the return on investment that's going to come in. Do you have any experience onto that which you would like to share?
Yes. One more good question in business perspective. Definitely, every business or every business owner will look towards the ROI. What is it and by when it will happen? So, definitely, this is an intangible benefit, as I already specified during my process of explaining it. So, yes, we can make it into a tangible calculation or an estimation based on our losses. Industry 4.0 definitely is not a theme or is not a concept. So it works for some organization in a different way, it works for the other organization in another way. Definitely there is no reflection here. It all depends on what the organizations are losing, at what point of time they are losing. As I told you, opportunities missed. It is all about opportunities missed. So because of not having real time data or because of not not visibly available data, sometimes we lose the opportunities. That is the cost what we are losing, and that is what we are going to save. The intangible benefits, how to convert them into a tangible chart, is the most important factor here. So we need to understand again the data point. So if an organization is having a lot of spend on their spare parts, machine spare parts, if there is a lot of time lost due to breakdown maintenance, that is where they need to collect that data point. Why, when, on at what pattern is my spare part getting damaged, or getting the life is getting over. So how can I be prepared, or how can I extend the life of the spare part? So only that data point should be collected. Investment should be done only towards that data point. So as again my point again comes to there, it is a top driven approach. So the top management or the data decision makers should have the exact control on what kind of data points they want, what data needs to be automated, what data needs to be integrated, what data needs to be visualized or displayed, and decision should be taken. So you invest low, you invest only on the data points which are your pain points, then you invest very less amount, the ROI will be quick. You can have a quick ROI, you can have advantage of profits from that data. That profit can be spent on the next pain point area. That is how the ROIs need to be calculated. Hope Om Prakash is satisfied with this.
Thank you, Ramana. We have few more questions. I hope we can take up those too. So
Sure.
in the way forward, you have touched base on the upskill part, especially, and we have one viewer named Sailesh Kumar Yadav, and he has asked that what are those key, skills should the production engineer develop to stay relevant in the Industry 4.0 era? And I believe many of the people, individual people who have joined this question will be relevant to them. So, from a production or a manufacturing engineer, what are those skills that one should develop to be relevant in the Industry 4.0 era?
Yes, very good question, Sailesh. Happy that you are not worried. Maybe Industry 4.0, maybe robotization, maybe automation would kill away my job. Yes, very happy that you are not worried about these things, and you want to be on top of the technology. You want to control the technology. The answer lies in your question itself, in your thought process itself. Yes, definitely we need to upskill ourselves to be above the technology, to make technology work for us. Otherwise technology will eat away, definitely, for sure, our jobs. I don't say you'll not have a job, but you won't have the similar kind of job. We all will have different kind of jobs to perform. Technology will change the pace of jobs. So coming to the skill set, what you asked me, what you expected from this, even this session itself, not from this question and answer. So yes, we need to upskill ourselves. Important thing is we need to understand the data first. We need to understand what is the difference between a raw data and a data point. We need not every production engineer who may be from a mechanical background. I don't ask each and every one of you to go learn about semiconductors, understand IoT devices, understand what sensors are, how a sensor perform, how a PLC will perform. No, that is not our job. That is the job of a software, that is the job of an integrator, a person who integrates the machine with the software. At the same time, I even don't say that we need to go learn software coding. We need to go and understand how to make a software to create an API to analyze the data which was collected from the machine. We as a shop floor teams, we need to understand what are those data points which are based on real time we need them. So we need to identify those points, and we need to identify how to integrate them with the system. A integrator, a semiconductor expert or a sensors expert cannot know a mechanical machine more better than you. You are the expert of your machine, you are the subject matter expert of the shop floor. So you better know where he can tap the data, how he can collect certain data point which may not be recorded in a PLC controlled monitoring system. So that is where we need to skill ourselves. We need to understand where all we can tap to get the data, where all the cycle starts, where the cycle ends. That is where we need to focus more on the data points. Definitely, we need to have basic knowledge about IoT devices. We need to have the basic knowledge about connectivity part. We need to understand how a cloud software performs, how an API performs, how an integration happens, how the data is visualized, how the data is transformed onto dashboard. For all that, data has been curated, and definitely we can support you in understanding it in a more better way. I hope
Thank you,
Sailesh.
Ramana. We have one more last.
Yeah,
Yes, we have one more last question that we are already over the time and would like to respect others' time as well. So this question is from Vidya. She is asking what government policies can help in adoption of smart manufacturing, whether they are there or if you think as a consultant, if you have to suggest. She is asking from that perspective.
very good question. Probably, I'm not the expert of this type of thing. A financial expert can help it out in a more better way, but definitely on a overview, I can explain it. Any government scheme or any government aid or any benefit what government gives, definitely it is a capex improvement part what they will help us on. Definitely there are many schemes, many CGTM schemes, central government upskilling schemes. If you want to upskill your team, there is upskill schemes from central government which will support you in upskilling your teams, which will help you. So there are many platforms which will provide you with upskilling things. At the same time, for the capex improvements also, there are many banking support schemes, many schemes from banks like SIDB, Small Industries Development Bank, all these things. But again, the most important point here is how you project the ROI, how you project the tangible benefits. The industry 4.0 benefits are intangible. We need to convert them into tangible benefits. That is where we can make a investment DPR, a detailed project report, which will support us in getting benefits from the government schemes or from the banking initiatives. But definitely, probably a financial expert will elaborate this in a more better way.
Thank you, Ramana. And we would like to thank all our viewers who has been watching and thank you for putting up all those live questions and making this session a very engaging one. And Ramana, as I said, that I hope our viewers must have got a gist of, onto this topic. Although this topic is very vast and it takes, that's where it takes a lot of time. And for the same, we have curated the program. So if any one of you who are watching us and want to have a more in-depth knowledge onto this area, please register your interest. The interest forms are already put up in the chat. Thank you again, Ramana, and thank you to all the viewers.